folks. Today we are going to use in our white packet, we are going to use problem number 4 in order to show what happens when we put both series and parallel resistors together. Alright, so first thing that we have to do is we have to run the current. So if you would look, you find your battery, you find the negative, the short side, and you start, pick one color, pencil or pen, or one diagram, and we start heading out. When we get to this point, we have two options for the current to follow. It could go up and over to get back to the battery, or if it hits here, it could go all the way past and back up, and then over and back through. Okay, from here we have to determine what is a series resistor and what is a parallel resistor. A series resistor means all the current flows through it. There's only one way to get through, so all the current eventually flows through, whereas parallel means the current splits, so only some of the current goes through those resistors. Okay, so as we look at this, if you can't tell which of these three resistors gets all the current, then you need to look for colors. Okay, all the current would be both red and blue. So as you look, resistor 1 only gets the red current, that's only some of the current, so that makes it parallel. Resistor 2 only gets the blue current, so only some, that also makes it parallel. Resistor 3, all the current comes back together, both red and blue travel through resistor 3. That makes that one a series resistor. Okay, step 1, we have to find the total resistance, the REQ. Okay, you have to do them separate from each other, the parallel and the series. So if you look, these two are parallel, which means we learned yesterday they have to go 1 over. So we have to start 1 over REQ is equal to 1 over 75 plus 1 over 25. When you add all of that together, you get a really small decimal. You get like 0.053 repeating. That is not REQ, that's 1 divided by. You have to do that quick flip. You have to take 1 divided by your decimal. Don't just keep it in your calculator. Take 1 divided by the answer, and you should end up with 18.75. That is the resistance for these two. This one's series, which means you just add it normally. So to those, you add the 50 ohms, and you get a total of 68.75 ohms. 68.75 ohms is the total resistance for the circuit. So parallel ones first because they go 1 over, get your answer for those, and then you add it in separately. I'm going to switch colors so I can use red and blue here later. From there, second step is always to find the total current. We always use delta V equals I times R. We take the voltage of the battery, 50. We take the total resistance, which is 68.75. We divide under, so we take 50 divided by 68.75. I'm going to round to 2 decimal places, so my current is 0.73. Alright, from here, I am going to go through and I'm going to get myself a place to work for under each of these by putting an I and a delta V, just like I did previously in other problems. I will also work out the problems down here. You just pick one way or the other, that helps you. But I need a spot to put everything. So I1, delta V1, I2, delta V2, and then I3 and delta V3. Okay, so from this point, the only thing that we can do is start with the series resistors. Okay, we determined this was a series resistor, resistor 3, and a series resistor, we determined it was series because it got all the current. All the current is 0.73 amps. If all the current goes through resistor 3 and all the current is 0.73 amps, then I3 has to be 0.73 amps. It gets all the current, we already know that number, so that is a given. Okay, I'm going to also go ahead and put it down here, 0.73 amps is all the current. Okay, from there, it's a puzzle piece. It's gonna start knocking down these dominoes. So I now know I and R, now I'm gonna find the voltage of resistor 3. So delta V3 is equal to I3 times R3. I just found my I3, 0.73. I'm going to multiply that by the resistance for R3, which is 50. And if I multiply those through, I end up with 36.5. Voltage 3 is 36.5. All right, I'm going to put it in both places. I did my work here. Some of you will just use calculators, do your work there. Eventually, it all needs to go into the answer blank so I can find the answers for you. Okay, so series resistors have to get done first because they get all the current. Once we have the series resistors fully done, we are ready to jump to the parallel ones. Okay, I am going to follow and work in colors now. I'm going to start by following the red path. All right, so we learned yesterday that as the electrons leave the battery, they use some of their voltage to push through the resistors so that when it gets back to the battery, all of the voltage is gone. Okay, so if I follow the red path, I am going to go through resistor 1 and resistor 3. So some of the voltage gets used up here, some of the voltage gets used up here until all 50 volts are gone by the time it makes it through both those resistors. Okay, so if I follow the red path, I go through resistor 1, so delta V1. I then go through resistor 3 plus delta V3 has to add up to the total of the battery, which is 50 volts. Okay, great news. I already know the voltage for 3, it's 36.5. So delta V1 plus 36.5 has to add up to 50. Well, if I already know one of them, if I subtract it away from 50, I can find delta V1, and if I do a quick subtraction, it'll be 13.5. So delta V1, 13.5, 13.5. All right, so when you follow a loop, all the voltages have to add up to the total. The voltage here plus the voltage here has to add up to 50. I already knew that voltage. I subtract it from 50. The remainder goes there. Okay, as soon as I have done that, I am ready to solve for the current for that one. Okay, so I'm going to slide it up. I have an R and a delta V. I'm going to slide it up here. So I want to find I1. Delta V1 equals I1 times R1. Delta V1, 13.5. R1 was 75. To find the current that flows through that resistor, I just need to divide under, and when I divide, I find that I1 is 0.18. Okay, so I1, 0.18 amps, I1, 0.18 amps. Okay, so first I found the voltage by adding them together to get to 50. Once I knew the voltage, I divided in order to find the I. I am now going to switch to the blue loop and follow that path to find everything for resistor 2. Okay, so I am now on the blue path. All right, as I follow the blue path, the process is the same. Okay, as I follow the blue path, I don't go through resistor 1, it's not on the blue path. I go through resistor 2 and I go through resistor 3. So as you follow those, the voltage of the two have to add up to the total. So all the voltages along a path have to add up to the total, which means delta V2, the voltage here, plus the voltage here, delta V3, has to add up to the total of the battery, which is 50. Okay? Once again, I already know this voltage. It's 36.5. So delta V2 plus 36.5 equals 50. If I subtract, I once again get 13.5. 13.5, 13.5. Those are volts. Okay, check your work. They're parallel to each other. They should have the same voltage. Okay, so it splits. The current will be different, but the voltages will be the same. All right, my last step, I now am able to solve for that. I want delta V2 equals I2 times R2. I know the voltage, 13.5. I know the resistance is 25. When I divide that over, I get 0.54. So I2, 0.54 amps, 0.54. All right, so the differences between what we've done when we had parallel and series separately is how you first find the total resistance. You got to figure out what is parallel. They do 1 over. You add the 1 overs to get your total, and then whatever is series gets all the current. You then add that in normally. Once you calculate the total current, the only thing you can do is give the series resistors all the current. You then calculate the voltage, and on any loop, all the voltages have to add up to the total of the battery. So the way that you jump to the parallel resistors is through your voltage. Thank you.